Welcome back, parents, friends, and teachers. Now we will start our this year. Uh, we will we will resume our STEM week presentations, and we will start with our friend Mariam.
Welcome parents, my name is Mariam and my experiment's name is color changing walking water. So,
Do I play now, Mariam?
yes miss.
Welcome to my presentation of STEM Week 2020. So, I am in science and the experiment I have chosen, its name is color changing walking water. So the ingredients I need for it are some cups, paper towel, water, food coloring, and a spoon. Now I'm pouring the yellow food coloring. Now we will be folding the paper towel. So we have to fold the paper towel like this. I'm going to press it down a little. And here I have done the other paper towel earlier. Then we're gonna fold this in half. And we're gonna do the same with the other paper towel. Then we're gonna carefully place the paper towel into the colored water and the empty cup like this. And we're gonna also do the same with the other colored water cup and the empty cup. And the paper towel will help the fluid to move one place to another. Now we are going to see a time lapse of 30 minutes.
Okay, Mariam, thank you. Would you like to explain?
Yes miss. Miss, so you might be thinking, what is this? Why I have given it in science? Because it works like with a little bit of a thing called capillary action. You might be thinking, what is capillary action? Capillary action is the movement of liquid along with the surface of solid. Essentially, the adhesive force between the paper towel and the water are more powerful than the cohesive inside the water itself. You might be also thinking, what is adhesive force? It is the attractive forces between molecules of different types are called adhesive force, and cohesive force is the action of or property of the molecules like sticking together. And this results in the paper towel pulling the water up, and the more water tries to come and pushes the water out from the other end, which happens with both of the paper towel. And because the cups don't have a similar color, what the water makes it a different color.
Thank you, Mariam.
That was Mariam with a wonderful video and her explanation. And now we'll be heading to our next participant, who is Marju. I Marjuk may not be there for some technical issues.
He's there. He's
So
there.
let's
Nimrita,
go
he's
on.
there.
Marzuk is here. He is
Marzu,
here.
can you please unmute and start screen
Okay.
share?
Yes, I will show how I did because
Okay,
I can
yes.
screen
Please go ahead.
because,
Yes, you can do it live. That's fine.
Miss, will I show the steps because kind of
Is it the similar experiment? Okay, you still explain the way you want. That's up to you.
okay, Miss. The research, my experiment's name is color changing walking water. The resources that I needed were 5 glasses and 3 colors, tissues, and water. So step one, I took 5 glasses and put color water in 3 glasses, and then took some tissues and put them like this. Then the tissue absorbs the color water and passes to the other glass, and two waters mix and make another color, like blue and green. Blue and yellow will mix and make green. And the reason of this is because of gravity. And the system is called capillary system. Capillary system is there are molecules in the water, and when the tissue goes inside the water, the molecules stick with the tissue, and the water and the tissue absorbs them and makes another color. Thank you.
That was Marju with another wonderful presentation. Now we will be going on to our next participant, who is Maisha. If Maisha is there.
I think we
I
can
think Maisha is
forward.
not here. Nimrita,
Maisha
you
is
can
not
go
here.
on.
Okay, miss. Then let's move on. And now I will be presenting. And parents, I will tell you about my STEM Week project, which is Oobleck. The resources which I use to make oobleck were cornstarch and water. I first took some cornstarch and I mixed it with water. Then I had waited a few minutes and it came to its real shape. I have learned that there is a thing called a non-Newtonian fluid. When you run your fingers slowly through a non-Newtonian fluid such as oobleck, then the oobleck will act like a fluid. But when you apply rapid force, or as you could say, give it some hard and fast, then it will act like a solid. Now, why does oobleck act like this? Oobleck acts like this because of its viscosity. Viscosity is the rate in which a fluid flows, and non-Newtonian fluids flow at a different rate depending on the amount of pressure applied in them. You may ask, why did I use cornstarch only and not flour, cement, powder, etc.? Well, I used cornstarch because as a result, the cornstarch particles in water actually repel each other slightly, held apart by forces which are so weak that they cannot affect something as small as a grain of sand. This repulsive force helps the slurry flow as the particles prefer a layer of fluid between them. Thank you, parents. That was my presentation. And now,
Nibrito,
yes,
1 minute, Nibrito. Can you please show your oobleck and turn on the video? And how the
yes,
metal is sinking over there and how it is hard. Can you show those things?
yes, miss, I can. Then, miss, I
He was having some internet
yes,
issues. He tried to connect his
yes,
video
it's okay.
and
I
yes.
have my oobleck right here. I wish I could show you with the, yeah, now I can show you. I have my oobleck right here, and when I apply rapid force, the spoon, as you could say, does not get in. And when I slowly give it, as you can see, it's sinking in between. And if it was a fluid like water, then right now if I punch it, then it would all flow away. Now as I'm punching it, it's not flowing away. And now as I'm keeping my finger is getting in slowly because of its viscosity and of it being because of it acting like a fluid. Thank you.
Thank you,
And now,
Nibrito.
Well explained. Very well
welcome,
done,
miss.
Amrito.
And now we will head on to our next participant, which is Mushfiq.
So, good morning, parents, friends, and teachers. So, for STEM week, I did a chart presentation on the use of decimals in our real life. So, here it is. So, as you can clearly see, there is a chart work that I have created. Here, I have drawn four different situations to show the use of decimals in real life. So the first situations that I have did is shown drawn a situation where a person is buying 1 kg of apples, which costs him $1.99. So that means it's the price tag of the uh, thing that I want to buy, so, which is apples. So here at this situation, I try to show the use of decimals in the price tags, which shows the price of different things we buy in our life, such as different groceries,
I
then
think our friend Mushfiq might have some technical problems. Mushfiq, are you there?
Yes, we
yes,
can
I'm here.
see him. We can see him. Everything is fine.
Mushfiq, can you use the room light for showing this thing because it's very
Our
dark.
friend Mushfiq might have some technical problems, so we will go on to
Give
our
him
next
okay, Nibrito, just give
participant,
him
which
another minute.
is
Maybe
Safa.
Nibrito, give him
Nibrito,
another minute. Just give him another minute. He is trying to fix it.
Okay, Miss, move on to Safa. I will do it later. Just I need to fix it a little bit.
Okay, no problem. Let's move on to Safa.
Okay. Good afternoon, dear parents. So now I will start my presentation, which is a balloon experiment. So let's start. Uh, so in this experiment, we need vinegar, we need spoon, we need food color, we need empty bottle, we need a balloon, we need empty cup, we need baking soda, we need funnel. So instead of a funnel, I'm going to be using bottle's upper part. So first we're going to pour 1 cup of vinegar. Then we're going to be using the funnel and pour the vinegar. After that, we're going to put some food color in the bottle. Then I'm going to be putting the balloon in the funnel to pour the baking soda more easily inside the balloon. After I'm done putting the balloon inside the funnel, I'm going to start putting baking soda in it. Then I'm going to take 1 tablespoon of baking soda and pour it in the balloon. Make sure the baking soda goes inside the balloon properly. Then I'm going to take out the balloon from the funnel. Then put it in the bottle's cap.
So this is all about my balloon experiment.
Thank you, Safa. That was wonderful.
Thank you, Safa. Well done. That was a beautiful video and a wonderful explanation. And now we will be heading to our one and only last participant of this session, who is Sharaf Zayan. Sharaf, you may take the stage.
Okay, thank you. Okay, so hello everyone and welcome to my STEM week presentation on my engineering project, the battery powered vacuum cleaner. So a vacuum cleaner is a machine that uses wind force to like pull the dust and waste towards itself to clean things around many areas. And for this year's STEM project, I have made a mini vacuum cleaner. So the resources I have used for this project are I have used I've used a battery. I have used some metal steel plates to connect the battery to the motor. I have used some wires to connect the power source to the motor. I have used a motor. I have used a fan. And I've used an empty shoebox, and lastly, an empty tissue roll, and also have used a hot glue gun to like fix everything together. So these are all the materials I have used to make this project. So this, as I told, the function of this project is to use wind force to pull things toward itself and clean things. So how that function works is that, as you can see, that I have used the battery. The battery powers the motor using two steel plates over here. If I connect the steel plate with the battery, it will start moving. As you can see, the fan is moving. So I have used some clip wires to connect the battery with the motor. So like I can divert power from the battery to the motor to spin the motor. But if I spin the motor, it's just being a fan. So that is the main idea. So for a fan, we need the positive like side of the battery and the positive side of the wire to connect to each other, and the negative also. So like what I have done here is inverted the like sides of the battery with the wires. I have connected the positive side of the battery with the negative side of the wire, and the negative side of the battery with the positive side of the wire. So it makes an inverted power. So what that means is if I like put an inverted power into the motor, it will make the motor spin anti-clockwise. That means the fan will also spin anti-clockwise and make an inwards going wind force. How that works is making it and like spin anti-clockwise, it is pulling wind pressure. So like by pulling wind pressure, it is propelling it to the other side of this motor. So if I make the fan spin, then it is pulling wind pressure and propelling to the other side over here. So as you can see now, if I like power the motor, as you can see, the motor is spinning over here, and it is making an anti-clockwise wind force. So that is how this mechanism works. And by using this like inverted wind force, I can like use this idea to like make the wind carry small pieces of waste and dust and like clean things around many areas. And now I will demonstrate how this works. So as you can see, I have put a little piece of tissue right here to like use the machine to demonstrate it. I have put the tissue over here, as you can see. Now I will turn on the machine and show you how this machine works. So if I just turn on the machine right now, as you can see, the motor is spinning. And now if I put it close enough, you will see it got inside. And here is the tissue paper in the machine. As you can see, this project works by using the wind force. So that is the demonstration of my project. Now, what I have learned from this project. So my main learning from this project was about how we can use wind force of inverted or like direct. So like it can, if it like if there's like inwards wind force or outwards wind force, and how can use it. And also I have learned about how we can like change the positive and negative connections, like make inverted power sources. Okay. And like how is it connected to real life? It is connected to real life by like as it is a vacuum machine, as I told. And vacuum machine is a real life machine that is used to clean things around many areas. And also it is connected to real life through the like the power, the sources that I've used, and like the so like elements I've used, like with the wind force I've used and the power sources I've used, like it all connects to real life, like reality. So that is how it's connected to real life. And also that is all for my presentation about my STEM week engineering project, the vacuum cleaner for this year. I hope you all enjoyed and thank you.
Brilliant presentation and
That was,
wonderfully explained.
that was,
Thank you so much, Sharaf.
yes, that was a fantastic presentation. And I may ask parents. Parents, do you have any questions towards any of our presentations in this session? Yes, Farzana Miss.
No, I just showing my appreciation to Sharaf. It's a brilliant thing that he made, and we are also very happy to see this thing.
Yeah.
Excellent risk taker and an excellent inquirer, and you explained the thing very nicely. Well done, Sharaf.
Thank you, Miss.
Could I like tell something? Say something?
Absolutely. Please go ahead.
Yes, Alvin, continue.
You know how he said like inverting the power to make the motor spin the other way? Technically, you could like make it pull the air by just switching the which side the fan faces, like the propeller space faces. So like just make the front, go to the back, just flip it around, done. You don't need to mess with any
Yeah,
power or anything. That's like
that
basically
like
the
that was my
simplest way of
idea
doing
at
something.
first. Like
Yeah,
that
you
was
could
my
have just
idea at
done that.
first, but like I mistakenly like like put the wrong word then, and that's how I discovered like how to change the negative and positive
Like
sides.
you can also
So
do
like
that by
that was
just
like in
flipping.
inwards like project discovery.
Okay.
So like that's then that is an easier way to
That
do
is
it.
how the
Like
learning
so
actually
like
takes place. So during the process of preparing this project, you
like
learned what really works,
like
what not.
so like I want to like share a challenge that I faced in this like project
Yes,
I've
please share
like
with us.
done. Like so first my main idea like for my first project was and like lemon battery powered like vacuum cleaner. But and lemon battery powered like battery does not produce enough power to run a motor. So like I discovered that and like I had wasted like 1 to 2 days like making that project. So like
Can
I
I?
like quickly came up with the idea to use batteries. So like that was an like challenge that I faced, and also like to like how will I like connect the batteries also. That was one of the challenge. But I like later discovered that I can use one of like my like I just used some toy like steel plates that I had for like an engineering kit, and I connected the batteries with the like the steel plates as I have showed here. Like I use these steel plates to connect the batteries like sides, and that is how it like diverted power to the motor. So those were my discoveries and challenges in this project.
So lots of new learning from your experience.
Yes, miss.
Okay. Anybody else have any questions or?
Yes.
Hello, Miss.
Yes, please.
This is
Please go ahead.
Yes, please continue.
yeah. Any of the student? This is Sharaf's father. I was watching as well at the request of Sharaf, and I also watched few other students' presentation. All of them have brilliant mind, very inquisitive one. We really enjoyed your presentations, Sharaf and others who presented in this session.
Thank you so much. Thank you. Thank you for your time.
Thank you very much for enjoying our presentations.
Can I say something else? Can I say something else?
Yes, Alvin.
You know, right when Sharaf announced that he was gonna said he was gonna when I knew that he was gonna make a lemon powered vacuum in the first place, I warned him immediately. Lemons will never be able to generate, even if you have 1,000 lemons, they won't be able to generate enough power for a vacuum running continuously. I warned him right at the beginning.
It's a good lesson for Sharaf also, but we need to try again and again to see to get the success. Okay, so that's a good learning.
Exactly, and that is why we cannot really depend on our assumption. We have to try to see if it works or not, and that's what it is all about. And yes, any other questions about anyone like other projects that we have got in this session?
We have 1 minute left from this session. So if you have any queries, any question, anything to say?
The rest of the participants are going to start their presentation from 12 o'clock slot. So we are going to conclude this session here.
I think Nibrito, you can mention the next timing.
Okay, miss. Thank you, parents, for watching. Thank you a lot for watching till now. And we will have a break from 11:30 to 12 o'clock, right after this meeting. So please join if you want to, and enjoy more of our friends' presentations who are wonderfully intelligent and know what they are doing and also are inquirers. Thank you.
Thank you so much,
Thank you,
everyone.
Nibrito.
Enjoy
So
your
our
break.
next slot will start at 12.
12 o'clock, yes. Have a good break, everyone. We'll see you at 12 o'clock.
Okay. Bye, miss.
Bye.
Thank you.
Thank you. Thank you so
Thank
much.
you. Bye. See you at 12 o'clock again. Janice, please, আপনার কথা শোনা যাচ্ছে না।
Is it clear now?